Hello guys, so let's continue creating our controls. So here in the gas vortex confinement there is the control settings, and it's pretty the same thing that we had before in the gas shredding and the gas turbulence. It's just a control field and control minimum and maximum, the control influence, and we're going to apply them in the same way. So if you want to escape this video, if you already saw the way of applying control fields, you can just close this video or skip this. Okay, so what I just want to show first is that it uses a control field here that is called confinement, and this confinement field is a field that is by default created by the smoke solver. So if you play the simulation here, you will see that there is a confinement field here. This field is just created by the smoke solver or the smoke object by default. Okay, and if we just jump outside here, if we use a node called DOP import fields, okay, in this node we can import any field from the DOP networks into the sub level, okay, to show it. So here we can choose our DOP network. We can drag and drop this one here. Oh, I'm sorry, this DOP network, we can drag and drop this here, and the default object we can choose our smoke object, and we have here the fields to import. So here we can choose a field that we want to import in SOPs. So if we choose our smoke object and type confinement, now we have this field here, which is just a field that is just a constant value of 1 like this. Okay, so if you if you just edit this field here inside the DOP network, you can just edit it and you know, create any custom field to control your vortex confinement, or you can use the density instead of the confinement field. But this field is created here in the smoke solver with constant value of 1, so it will not change anything in your gas vortex confinement by default unless you play with this field, change anything in this field. Okay, so anyway, here you have just a control field you can control using density, temperature, and anything, and you have the default controls, but it uses this confinement field, which is 1, and multiplication by 1 is 1. Okay, if you remember, we were just multiplying the control field. Okay, we're multiplying our force by the control field, and if the control field is just a constant value of 1, it will not change anything. I hope this is clear. So we are going to add our controls or our control settings here and our visualization settings, and as you remember, we here have our force stored in this vortex direction field here. So what we are going to do after this is that we are going to do a gas field VOP, to do the control field stuff, and I'm going to do this very fast because we did it before 2 times. Okay, so now what we are going to do is that in this let me choose all of these things here and choose create a subnetwork. Okay, and we're going to rename it to Vortex Confinement, okay, as we did before. And in this parameter interface here, we're going to create a folder, call it control field control settings. Okay, control settings. Okay, then we are going to we are going to create a string here inside this and name it control field, control field, like this. And as we did already before, in the data bindings here, we are going to add a new binding, and we are going to type our expression, the pactic and chs quotes dot slash control field. So now we are referencing our control field, which is a string, and we're using a chs, and we are using the backtick because here we cannot put an expression in this without the backtick. And we are going to use the name of control. Okay, so whatever we enter now in the control field is going to be binded here, going to be bound here. Sorry, if we just create a parameter node and name it control and make it invisible. Now we have our control field. If we just create an if block, we can promote a parameter, call it enable control. Okay, why isn't it working? Yeah, enable control, enable control field, and it is a toggle. Okay, and as we already did before, we can bind our vortex direction and choose a 3 floats vector. So if the condition is false, we are going to return a constant of 1. And if the condition is true, we have our control range and we're going to fit range it. Okay. Promote the parameter, promote also this parameter, and rename this to control min, control minimum. Okay, and here control max and control maximum. Okay, so now we're also going to add another if block for our ramp parameter. So let me promote a parameter here, enable control ramp, enable control ramp. So now if the condition is not true, we are going to use our fit range. But if the condition is true, we are going to use a ramp parameter to control our range here. So we are going to call it control ramp, and we are going to use a spline ramp. Okay, now we are going to make this our output, and this is the output of the other if condition So now if the condition is true, we are going to fit our control range and see if these are checks. The ramp parameter, it will if enable this control ramp. If not, it will return this fit range without any change. And all of this is going to be the result if our first if block here is true, but if it is false, it's going to return 1. And now we can just add our complement stuff, or the control influence. So we can add a parameter and call it control influence. Oops. Control influence. Then we are going to find the complement of this control influence and the complement of this here. Then we're going to multiply the two complements. Okay, and now we can add the result to our control field. Then this is the output of our indef now. So now we have all of our parameters. We can revert this one to default. Okay, here in this control ramp, it's toggle here. Okay, now what we can do is that we can edit our parameter interface and go inside, use your parameters, enable control field, your control minimum, your control maximum, your ramp, and your ramp parameter here, your control influence. Okay, so now you have all your parameters. You can set the values, the control minimum and the maximum, and the control influence default is going to be 0.5. Okay, and as we did before, we can put our expression now, which is enable control equals 0. Then let me copy this here and here and here and here and finally here. Then also in the ramp we are going to put another expression for the other toggle. Okay, so now we have our control settings. So what we did here is very simple. Okay, the same stuff here. If the condition is not true, just return 1. Okay, and if the condition is false, do if the condition is false, return 1. If the condition is true, just do all of this stuff here. Okay, and then here we had another condition. We have, if our condition here is false, we are going to use the fit range without any change. If it's true, it's going to remap it, and we have the complement stuff that we already discussed before. And now we can multiply our force with this control field and add another bind export node. Call it Vortex direction. So now we have our vortex direction here with the control parameters. After that, we want to apply our force to our velocity as we already did before. So we are adding a gas linear combination node, and we are going to use the combine operation. We are going to add our vortex direction to our velocity, then store this in the velocity as we already explained before, but we are going to multiply our vortex direction by the time step, and we are also going to multiply it by the voxel length. And this is what side effects did, because they want to scale the force by the voxel length here, okay, which makes it more reasonable and prevents the simulation from exploding or preventing unexpected stuff or unexpected results. And here in the coefficient here, we can just here create a float parameter outside here. Okay, not a label, just a float parameter. Put it here, man. And we're going to call it confinement scale. And the default value is going to be 1. So now we have this parameter here, and we are going to reference it in our coefficient here. So we are going to add ch/confinement scale. So now we are sort of we are here adding a multiplier here. So now we can scale our vortex direction before we add it to the velocity. And here we go. We have now our vortex confinement. So and of course we can add a vector field visualization and add a visualization to our vortex direction, and add a visualization tab here. Okay, a visualization tab here, and do all of the stuff that we already did in the last videos with the shredding and the turbulence. We can also clear the temporary fields, and I won't do this again because it will, you know, take time, and I don't want to waste your time. Okay, so now we have our vortex confinement. You now know the idea behind it. Okay, thank you for watching.